Hi, I'm Tom and I talk about code. Welcome to another Rust programming livestream. Today, I'm diving into the deep internals of my virtual machine. Last time we hit a lot of borrow checker problems. Sorry, my microphone is off. I hit a lot of borrow checker problems and I'm going to redo the intro. Had to adjust the microphone. It was rotated wrong. Okay, let's go. Let's do it. Hi, I'm Tom and I talk about code. Welcome to another Rust programming livestream. Today, we are going to dive into my virtual machine internals. We're going to refactor a memory API that was giving me a lot of trouble last stream. We're going to look at wonderful Rust types such as RefCell. If I can write, cell. RefCell of RC, of box, of RefCell. We're going to look at wonderful types like this, okay? This is the Rust rabbit hole that we're diving down today. Last time I had a lot of trouble nesting these types, and basically the first time I did these memory APIs, I half-assed it, and I really paid the price for that last stream. Just eat some RAM, it goes well with chicken. Excellent. Thank you. Well, oh, I can't. That's not on stream. Thank you, Vibane. Welcome, welcome. Looking forward to your input on whatever I do here today. So, actually, we need to draw a picture. We need to draw a picture. We need to draw a picture of what we're trying to do. So here's the goal, right? We have our virtual machine has. We need a better color for this. Our virtual machine has memory, right? And the memory is kind of like a big list of different memory devices. So there's like a buffer over here, and there's like a buffer over here. And when you write to an address, it kind of goes through this translation layer and it ends up in the right place. But then maybe over here, we just have like an I/O device that when you write to it, it prints. And when you read from it, it reads from standard in. I missed a letter. Cool. So, this is the basic structure that we want. Now, when we map this thing in, right, we want to map this in to the virtual machine. We want it to be owned by the virtual machine. Let's draw that with an arrow. Let's say owned, right? These things are permanently linked together in ownership. All of these things are owned by the virtual machine, okay? But we also want to be able to reach in and borrow this to inspect it later on for testing purposes. That would be really useful. That would be really useful. So we want to be able to borrow. Now immediately I see the thing that was missing last time. Well, so what we could do, right? What we could do, last time I was trying to do a lot of ownership stuff and I drew a picture that I'm actually quite proud of, right? That represents this owned borrow example where I drew a hat, right? And I gave the example of a magician. And I'm going to draw this again because I'm so proud of this as an example, right? So a magician has two hats. They want to put a rabbit into this first hat. Okay? They want to put it into the hat and they want to pull it out of the second hat. So these two hats behind the scenes are both linked to this same physical box, right? And the hats they're kind of like an interface, right? They have a get and a set method. That's all we really care about with them. That's all we really care about with them. So what structure in Rust represents this? Well, this is what I was trying to do, but the thing I realize now is we could actually just ask the virtual machine, this is the mapper. We'll call this the mapper. Right, the thing that maps an address to a device. We could actually just ask the mapper to get the addressable here, and we don't actually know what type this is, right? All we would get back is an interface object, but an object that implements an interface. But we can force Rust to cast this to something else, so that's an option. Failing all else, that's an option. The only case we probably really want to do this kind of inspection is in a test, maybe. So maybe this is unnecessary. But what would be really nice is, and actually now that I start talking about it, I can see the problem. So instead of having this strict ownership thing, if we could actually have this structure where we have our mapper, we'll call it M, and it's just like a big table of things, right? So our VM is up here. The mapper maps certain ranges of memory into devices. into like either a buffer or a thing that knows how to read and write things, right? An addressable. and this one is our IO device. And actually, let's put a little blue box on the inside. What I was trying to do last time was to say, actually, hey, your owner is over here outside of the virtual machine, right? Off in some other space, other part of the program. Owned. And the only thing that was owned here was the kind of reference to it, right? So the virtual machine owns a thing, let's say, owns a pointer, right? A thing that points to this same memory. But the actual owner lives outside of the scope of the virtual machine, because when you create a virtual machine, you pass it in. So the owner will actually probably outlive the virtual machine. This was my thought. And this is a much more complicated structure, and I don't actually know what types would enable it. I think my layering of RC was incorrect. I think that is a given. I think that's really a given. So maybe what we need to do, owns a pointer is a little bit problematic here, okay? But maybe an RC does kind of solve this problem, right? Overall, I think we need to go into this code. I need to start a recording. Actually, no, I don't want to record. I don't want to record this. This is in a VM work. So we're going to go into memory.rs, and we're going to look at what this type is. We're going to look at what this type is. And this type is an RC of a RefCell of a box. Now, that's kind of a crummy type, okay? It's kind of it's a very crummy type. Why? How are these memory records used? Mapped? How are these used such that we need this to be wrapped in a RefCell? Okay? We iterate over the list. I think the reason that I need this to be I think the reason I need this to be like this is because I return, no, but I don't return a pointer to it anymore. I just return an index to it. So I don't even know if this needs to be a RefCell anymore, honestly. Memory mapper. We get the thing that's mapped. We get the index of it. We get we get the index of it. We get the thing at that index. So why do we need to borrow this? What do we do with A? Try borrow mut. Why is this here? Can I just try and rewrite this without the RefCell? What's going to happen? What's going to happen? We've already mutably borrowed self. I think that's the problem, right? Because this already mutably borrows self. Like we have to mutably borrow self to get mapped. We can't then additionally mutably borrow A. So this is what I believe we talk about when we say internal mutability. Is that what that means? Is this internal mutability? The owning thing's already borrowed, but we use runtime assertions to borrow a thing within it. You don't see your interest either. Okay, let's try cutting them out. Let's simplify this. Let's start with the simple thing, because the whole reason that this got complicated to start with is originally I was returning an addressable here, right? I was actually returning the thing on the inside rather than an index to it. So let's try and simplify this. What if we just make this a box? Now a box does not solve any of our problems. Oh, it is interior mutability? Okay, so RefCell is correct. RefCell is correct, but RC is not. Let's go back to, this is what it was before the start of last stream, right? A RefCell to a box. Okay, let's do it. Let's get rid of RC. Let's go back to what was simple and what worked. So we need the RC. We need the RC. We're going to get rid of this weird function that I added. Map ref didn't really make much sense. Bobby is welcome. Also, Prof Elements, welcome. Sorry, I forgot to say hello. But thank you guys for stopping by. Always good to see people here. Bobby, you mentioned something about weak, right? Weak reference. I don't know what this is. RC that holds a non. Yeah, so this actually sounds kind of similar in a way, right? Calling upgrade on a weak pointer which returns an option RC. Since weak references do not count towards ownership, it will not return the value stored in it being dropped. Go guaranteed, blah, blah, blah. So maybe I do want a weak reference. I don't know. That's interesting. That would be, this sounds like it's actually a much better type because, I don't know. But yeah, so we're gonna simplify this again. We're gonna simplify this again. Oops. What happens if I build now? RC. Okay, RC's out of here. Map ref not found. Let's get rid of you. We're just gonna undo what we did. Okay, cool. So that builds, and that test's gonna blow up because we use APIs that don't exist. Nice. Beautiful, beautiful. Okay. Now, I can make all my problems go away. I can make all of my problems go away if I just add dot memory dot. So what does our VM? Our VM has a memory mapper, so we can use the memory mapper methods. So we could just add a method to memory mapper that says, well, we can just do it. We can just do it, right? Or we can say pub fn get addressable, maybe, and we'll just get a reference to it. Can we borrow it? Can we borrow out of a box? Sure, why not? Well, how does that work? How does that work? How does this borrow work if it's a box? Because we can't clone the RefCell. If we could clone the RefCell, it'd be fine, right? And this is the thing. So to try to enable this, right? The thing that I wanted to try and do was have a nesting of types, to have a RefCell of RC of box. And I think I tried this last stream and it didn't work for some reason, right? Now, one question I have is, do I need the box if it's in an RC? I think I do. The RC only does reference counting. It doesn't actually put it on the heap. So RC, like this box is critical because it's a Dyn object. It is a Dyn object, so we need it. We need the box. Box is required. Beautiful. So we have a box. We have a box. The RC is because we can't clone the box, but we can clone an RC to a box, I believe, right? So, right? That sounds right. So let me Google this. Rust, can I clone RC box? Because you can't clone a RefCell box, and that's really sad. Is it possible to clone a box trait object? Here we go. Here we go. No. If you clone trait object is box. Ah, so we could say that the thing has to be clonable. That would work. If clones are part of the trait object, yeah. So wait, but what happens when you clone a RefCell? Rust, what happens when you clone a RefCell? Because I would think that the thing behind the RefCell should not need to be clonable, right? Clone. Yeah, it clones the thing under. It borrows and clones the thing. Self.borrow. Self.borrow.clone. RC a smart point. If clones are part of it, it makes RC a smart pointer a shallow copy. That's what I really want. I want a shallow copy, right? I want a pointer. I want a pointer. And I could do it using unsafe, but I would rather not do it using unsafe, right? I could make this a pointer. And that would work, right? Instead of a RefCell, instead of anything like that, this could just be a direct pointer. But then I need unsafe everywhere, and I'd rather not do that. So what's the safe pointer that allows ownership to live out here, but this thing to also reference the same data, right? 2 points referencing the same memory. And runtime asserting, like I thought that was what RefCell did. I thought we could runtime assert that two things could access the same memory, just not at the same time. This is why I'm confused, because I feel like I know the tool for this job, right? And so I'm back at the same place I was. So this is not what I want. I don't want clone on the underlying thing being called. Take and replace. No. If there are already multiple pointers involved, is RC a smart pointer, a shallow copy? If clones are part of the trait object, it makes... What was this in response to? Sorry, I got a little lost. Weak also sounds interesting. Hold on, what was weak? Weak is a version of RC that holds non-owning reference. So this sounds good. This sounds like I could make a weak... So what if so this is it has to be in a box. The box is required because it's a Dyn object. Someone left a YouTube comment who's been really helpful a couple of times, and they were like, hey, just don't use the box. And I'm like, no, I need the box. What cloning in RC did? Okay. RC. So RC is like a shallow copy, and that's good. Weak is a shallow copy that has a non-owning reference. So that sounds interesting. Upgrade returns an option RC. Weak is useful for keeping a temporary reference to the allocation managed by RC without preventing its inner value from being dropped. Okay, so no, that's not right. Circular references, whatever. That's not actually quite what I want. What I want is, it really feels like this, right? An RC of a box, maybe or maybe not wrapped in a RefCell. Let's try that. Let's try turning this into an RC instead. So then what gets passed in? What gets passed into this is an RC. So it gets passed into the memory mapper, right? We map in an RC box. And this is cloned. This is cloned. Right? So let's try this. Let's try this. RefCell RC. And the RefCell is still required because the interior mutability constraints are the same. This just means that we can have... Yeah, sure. Let's try it. I think there's a problem with this, and I think the problem is that we have to... I don't know what the problem is, actually. I don't know what the problem is. This feels okay. This feels okay. So what breaks? Other than this, we're not going to do that anymore. That's our last resort. Our last resort is asking the mapper to give us a thing back directly. Okay, we need to import RC. Okay, so map, expect an RC, founder, 93, map, start size expected, this 93. This. Okay, so this is now going to also be wrapped in an RC. What else have we got? Unwrap, cannot borrow as mutable. So unwrap. Oh, because it's mutable. It's mutable. Yeah, so we need to be able to mutate it so RC doesn't work. That's why RC doesn't work there. Yeah, no, there was a good point. It's good. The more types I read about, the better. So no, thank you very much. That sent me in a good direction. RC does not satisfy mutability. So Rust RC with mutability, right? What's the option? RefCell T. And this is what I have. So this is why I'm confused, right? Mutate data even when there are immutable references to that data. Okay, right? Because you can have multiple RefCells pointing to the... So hold on. Rust copy RefCell pointing to the same box. I want multiple RefCells and one box. Is that RC of RefCell? Because you get an immutable reference to a RefCell and then you borrow what's inside of that mutably. Do you need... Hold on. RefCell, give me the actual docs. Hello? Rust doc. Give me RefCell. Yeah, so borrow mutable does not require a mutable ref to the actual ref cell. It looks tedious to work with. I don't know if it is, right? Let me put it like this: an LSP wouldn't help me in this situation at all. I would be just as lost. I would be just as lost. Might be a little bit quicker to type certain things, but I feel like I would be more distracted by it than anything. And I feel like I'm back to where I started the stream, right? But if I wrap this ref cell in an RC, then I can have multiple copies of the ref cell. And the ref cell, we don't need a mutable reference to the ref cell ever. So I'm gonna try this again, even though I feel like this is what I just did. RC, new ref cell. Cool. Moving around my code looks tedious. I do also have I should use this more. Map. Okay, well that was not the tags file I wanted to generate. Does C tags do Rust? No, I don't. I think I need something else for it. But yeah, I've got I do have better C tags support, and this code base is getting big enough to justify it now. I should stop being stubborn. RC, RefCell, memory manager. Okay, so RC new. So now when we get this, what we have here is an RC that we need to. Oh, let's just see what happens. What breaks? Expected RC, blah, 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 found this. So this should be an RC of a ref cell. I think trying to support two different APIs didn't help too. Cell, ref cell. Okay, so this should be an RC new ref cell new. Addressable. This is a box, so this just again needs to be wrapped. RC new ref cell new. Closing delimiter probably meant for this. That is because I suppose I'm one or two closing brackets too soon. What else have we got? Unclosed delimiter. That's not good. What did I do? There we go. Yep, map RC box. So we want RC new ref. Wait, hold on. RC ref cell. Found. Self-VM. Yep. Okay. FN map. This one. RC ref cell box. Cool, expected a box, found this, yes, because apparently in memory, map. Oh, wait. Yeah, okay, so I did that wrong. In conclusion, that was some churn, that's okay. Box. Man, a lot of churn to add all these extra types. And this is a line noise consideration. What I was doing before definitely had a little bit of simplicity. Like, supporting not having this overhead if you don't want it is definitely, there's merit to it. Okay, so if I make T now, we're gonna get this thing yell at me because RC new. I don't know if that's true, Bobius. I can use a type alias to avoid typing out the definition, but I can't use a type alias to avoid this, right? This is the problem. Oh, best viewers on a shady link. Wow. Wow. Let's get rid of that person. They're gone. Cool. I love it. I love these bots. They're very funny every single time. Yeah, exactly. Why would I go looking for better viewers? Where else am I gonna find viewers that put up with this kind of weird Rust madness? But yeah, I don't like this. Unfortunately, I don't think is the case. There are definitely ways to do it, especially if you want to like do macros or something silly. But otherwise, yeah, you're just kind of stuck. I believe this is because I don't have cd rc and cell RefCell. What else have we got? Memory box new. Yep. This is in the VM test, of course, so std rc and also cell RefCell. I keep building the wrong thing. This is still going to break because of this test, and that's okay. Downcast, that can really... So this is what I had last stream, right? And there was a problem with this. So we could clone it in. But we couldn't borrow it back. Why couldn't we borrow it back? That's right. So this was the problem with this approach, right? When you actually try to use it, you get a type error. You get a weird type error. Unused import. What is going on here? Map ref. Oh, map ref not found. Hold on. There's a couple of things going on here, right? Okay, so this is the problem. We expected a ref cell pointing to a box that is an addressable, and we got a ref cell pointing to a box that is a terminal byte buffer. Now, here's my thought. Can I clone this, but do the type conversion over here, right? Will clone understand how to do this? Probably not, but let's start with this. RC ref cell box dyn addressable. Right? Can we tell Rust to use this thing in a slightly different way? That was the wrong thing. This is going to yell at me with the same error, surely. Oh, and I also just deleted it. That's very funny. Yeah, it'll just infer BB's type on the clone. Excellent. But now the question is there a way, even if it's unsafe, because this is a test, is there a way to force Rust to respect the type? Okay. Is there a way to force it? Yeah, there must be. So Rust cast box t to box dyn trait. Yes. Now this is kind of like what I was doing before, but I was doing it... They're not the same thing. Different size. Huh. Just well, yeah, what if I try an into? What if I... Into is magic. Box new. The problem is, once I can't make two boxes. I can't make a new box because I can't have two boxes that both contain this. That's the problem, right? The box ownership is ultimately the thing that's making this awkward, and the difference between a box of a trait and a box of a strict object is hard. Into. Okay. So into doesn't like this. And actually, yeah, you can't do this. You can't. You have to copy the data inside the box, and that's not possible because these boxes have different layouts. This will move it. This will move it. So you can't do it. You can't do it, right? It doesn't... I don't think it works. I don't think into works on any type, right? If that random Stack Overflow page is correct, and I am inclined to believe a random Stack Overflow page. Don't try me. I will trust them every single day of the week. I think that this conversion is not possible because it's only possible if you move what's in the original box, right? You can't just into it. It has to be a move. So what do we do? What do we do? How do we approach this? I'm going to run to the bathroom. That's a good way to start. That's where I have my best ideas. So I'll be back in just a second. Okay. So I have thought about this and I have still not reached a conclusion. The biggest conclusion I've reached is, why are we bothering with all of this just for a test, right? This is all just so that one test can pass. Wouldn't it be better to do something really stupid like this, right? So let's have our mapper, which has a list of things. These are the like blocks of memory that we map into a certain thing. We have a stupid little IO device, right? That has, it's kind of like two pipes, right? There's like an in and out, right? Usually they go to standard in, standard out, but in our case, we want to test what gets written to them. So what if instead of having a buffer that's in here that we want to look at the contents of later, right? And like do, some kind of observation of, why not just put the actual implementation of these in unsafe land and write some kind of shared global state. It's a test, who cares? As long as that state is local to that test, great, right? The local, static, not maybe the right word, but like what if we just do something unsafe in the test? Give it my own buffer. Doesn't that have the same problem though, right? But because what owns the buffers? That comes back to, sorry, I forget people can't see when I'm on the scene. Why not give your own buffer to read and write from instead of stand in, stand out? That has this problem though, right? Like, who owns the buffer? What does the buffer, like, how do we read from the buffer at the end? How do we get the buffer back to read? What does the buffer, what backs the buffer? Who owns the thing that backs the buffer? Unless buffers have indirection built in that I don't know about, and it's gonna do that magically for me, that would be great. But like, that's basically what I've done, right? Like, I've got a device that reads and writes to a buffer. It feels like I would have exactly the same problem. I could try it, but I feel like I would have the same problem. I forget it's called buff writer, not buffered writer. Let's have a look. Wraps the writer buffers as output. Inefficient write on every TCP stream. You don't own the STO buffers. Yeah, but the STDIO buffers are weird shared operating system state, right? Like, I don't even know how they work. They're smart pointers under the hood, but I suspect they're unsafe. right? I think the unsafeness of them would... Maybe I'm wrong. Maybe I'm wrong. Mutex to a buffered reader to std and what's std and raw? This is a rule. This is a side quest, but I'll take it. Std and... Okay, that doesn't exist in the docs. Rust, how is standard in raw imp? Wow, I love that the source is all here. Hold on. We can literally... Can I search this? No. But I suspect the actual data going through it goes via unsafe somehow, maybe, or just operating system magic. Like, yeah, they're a handle, exactly, right? You don't actually own the buffer, the operating system does. So it's a bit of a different... But the buff reader is the program side buffer, right? So, I mean, but there is a buffer that is shared. There is state that is shared. And that's why it has a lock method. So, yeah, so how do they... Wait, hold on, yeah, what the hell? How do they do it? That's literally the same thing, right? They have... Yeah. Okay, hold on. I see what you're saying. So... Let's test it again. Let's look at the source again. Mutex to a buff reader. So the buff reader... sorry, I want... Let's do standard out. Because I'm writing. Standard out. But where does the indirection come from? The mutex is interesting in this case, right? It feels unnecessary. Interesting. I'm still concerned, right, that I'm gonna have... So can you clone a mutex to a buffered writer? What happens to the buffer? Okay, so what we're saying here is, right, let me draw a picture on a new page for anyone struggling to follow along with this thought, right? So in Rust, standard in, or standard out, is backed by a mutex to a... No, sorry, it's a reentrant lock, which is different, right? I don't need thread safety. I don't need thread safety, right? I know what a mutex is, right? But I don't need the thread safety. But does the mutex somehow give it that guarantee, that the runtime guarantee it needs? Does mutex add an addition? Like, do I need something else instead of a mutex, right? Do I need a different type? So it's a RefCell to a line writer. But I can't make... So this doesn't solve the problem, right? I could do it like this, but I would still run into the same issue because the type here... I still have the problem of shared ownership. I still need to know what the type is here. No, but this can't be a buff writer. This is memory. These aren't just devices. This is anything that is addressable. So this includes memory as well. So this isn't just... I can't just make this a buff writer, right? There are other kinds of IO devices that aren't just... Like, this is just one kind of IO device. So the actual reading and writing of things is not the problem. The problem is that I want to hold on to a reference of a box wrapping an addressable, but passing this thing in, and I can do it, but I can't hold on to that reference as an addressable. No, sorry, I can't hold on to that reference as the thing. I have to do it as an addressable. And then for some reason, it's really awkward to unpack it from this type, right? It's really hard to take this. So I want to be, right? This works. This all works until I try to use it, and then it's like, why does it need to be dying? Well, it's a trait object. Like it's a trait. Like it has to be. Like I can't, what do I put there instead of dying? The idea is that because it's a, why do I need a trait object? Because it's a trait. Because my idea for memory is that it's like, the memory interface is homogeneous. It doesn't matter what kind of device is bound to an address. The idea is that memory is just a collection of things that can be read and written to. So in the case of, you know, the actual like memory of the computer, read and write to, you know, a underlying buffer essentially, but at specific offsets. Well, it explains why it's a trait. Like, what do you mean by trait object, right? Do you mean why am I using a trait? Like, why am I using this like an interface, or what the trait object is for? This record represents everything mapped to an address in the machine. So it has to be, and maybe it's too clever. Like maybe the problem here is that it's too clever. Why box instead of taking a type that implements the trait? So do you mean like type that implements the trait? Because then I would only be able to use one, right? I would lose, like I can't say, like I can't make this generic on F where F impl. Do you mean something like this? Instead of taking a type that implements the trait? Or do you mean in the function? But if I do this, then I can't mix and match different things. Right? I can't have a vec of memory record, like what type goes there. That's the problem. I want different things. There's not just one kind of addressable. There's lots of different kinds of addressable. That's why it's a trait. So I can't put them in a vec if there's not, like this, that doesn't work. There might be a different way in the function though, right? I might be able to pass it in a different way. The problem is then that, can I pass it in wrapped in an RC? Because this box is so deeply nested, I don't think I can unpick it and pass something else in here. Yeah, so I can't make it generic on something. I can't do that. What am I doing that I don't know the type at compile time? Nothing. I always know the type at compile time. The problem, so the place that you would fix this, right? The place that I think would be ideal to fix this would be able to say here, right? Instead of making it a trait object, it would impl it. But with this nesting of types, that doesn't make any sense. So are you saying that I could say, the problem still, right? Even I know it run at compile time, I don't need the trait object. The problem is still this vec, right? I can't have a vec of them if they're different sizes. So I can't have a vec of impl addressable, right? The vec is the problem here, surely. That doesn't make sense, right? You can't like that, because they're in a vec, they need to have a known size. Yeah. So this nesting is unavoidable, but is also the problem. Yeah, cool, awesome. I'm enjoying having my assumptions challenged. Oh man. So would that, okay. Here's what I'm gonna do. Hold on. Okay. Why can't they be the same type? Well, because they're different, right? They're different things. They do different things. They kind of fundamentally do. And because the interface of reading and writing to something, I don't think it maps well to a, like, it's not really, you don't want a buffered writer for your machine's memory, right? You don't want everything to go through a buffered writer. Once you try and make it homogeneous around there being buffered output, the whole computer starts to rot from the inside out, I think. so making it a trait, making it this kind of dynamic thing, I think has value. I think it's a cool design. It works really well on the JavaScript side, right? From the WASM side, I can bind JavaScript functions to be called when you read and write certain addresses. That's cool. That has cool implications. That has cool, like, it makes it easy to do certain things. Custom addressable for tests. Yeah, well, and that's what I've got, right? So in my test string, I do have, in common, I have an addressable that, where did I define this? What the hell? Terminal byte buffer, where did this come from? Lang tests, terminal, cargo B. Where did this come from? Oh, okay, I must have just accidentally munched that when I checked out. That's funny. I thought I'd committed everything. Oh, no, I hadn't. Okay, well, that's good. That's good. That's really good. Oh, crap, I just munched a lot of stuff. There was one test file I hadn't committed before I did that. That was great. I was like, I'll wait till I finish this. So, basically, I did have an addressable that was just for tests. And oh, I feel like I've made no progress in 50 minutes of stream. This is a good one. This is what you want. Okay, so how do I fix this? I don't know. Oh, I don't know. I'm going to go back. I'm going to undo all this crap with RC. I think that's bad. And I'm going to rethink how this test works, because I think that's also bad. I'm going to put this here. I have to redo this. That's really annoying. I never do a reckless checkout when you have weird state and you've been doing stuff for a while. Okay, so we're gonna go here. We're gonna go into memory and we're gonna simplify this, and we're not gonna recomplicate it. We're gonna get rid of RC. Every RC, it's dead. RC. Okay. Oh, mapref. Mapref is dead. It's gone. No mapref. Yeah, this is the answer. This is the answer. Why not have my test address will contain an RC or a RefCell to the thing? Oh, that's so obvious. Thank you. Yep. That's it. That's the answer. That's what I should have thought of 2 hours of stream ago. Thank you. You made it sound really simple. It is really simple. Oh, you just get stuck in that loop of like, I can fix this in my Rust types, and actually I was fixing the wrong problem. So yeah, that's a lot simpler than anything I'd been thinking of. So build works. T will blow up. A few things. Okay, so. It took some annoying questions. No, those were really good questions. I think that was really valuable for me because I got to defend some of the ways things were done, and I was right. I wasn't sure if I was right about them, but I was actually right about them, which is good. Like knowing that I did actually need the word dyn in there, it would have been really easy to convince me otherwise. I was like on the fence. I'm like, I'm missing something here, but I'm gonna continue to say what I think, and I feel more confident that I understand Rust now. So that was valuable for me as well. RC and RefCell can piss off from here. We split this function in half last time, so we're going to do that again. We're going to go to run program, and I want to be able to map extra things in here as we go. So this is going to become 2 functions. So we're going to call this, what do we call it? Build machine. Where we compile, we load to a VM, we set the program counter, and then we have the run part where we, sorry, that has to go after here. Then we have pub fsan execute loaded program, where we take a mutable reference, a VM, which is a mutable reference to a machine. Cycle count, halt, error with contact. This all looks good, except we don't need to give back the VM. Okay, and then run program, which takes a program, which is a stir, and gives back a result, which is a machine and a string. This just does let mut_vm equal load program, sorry, build machine. I really like that we don't need to specify a memory size anymore, because that's something baked into the binary format now. The binary tells the program how much memory it expects to use. We should probably have a sane upper limit on that somewhere, right? Something that says, hey, you probably don't need 5 gigabytes, but also it's a small number. There's a limit to how much you can ask for. And then we want to execute loaded program with a mutable reference to our VM. And then we want to say OK and give back the VM at the end. Cool. And that is not right because I didn't put things in there. Okay, this is cool. So all of that errors just come from this one file. Lovely. Let's keep this register. We want to check a register. What's going on there? Oh, it's because these question marks are really confusing the parser. That's okay. Bobius feels much less useful these last few streams due to spending times on languages other than Rust, but I appreciate your insight and perspectives on Zig. You've really made me more interested in Zig. I think it would be fun to do a little Zig game dev stream or something, right? Try and make a little platformer, or I don't know, something fun in Zig. Zig is on the cards for the future. Maybe soon. Also PlayStation 2 stuff. I really want to get back to it. I want to block out 5 or 6 hours to sit here and bash my head against the vector unit. So let's make an addressable, and let's put it in common. Tests common. Let's say pub struct, and we'll call this a shared buffer, okay? We'll call this a shared buffer. This is a bad name. We'll call it a shared buffer device. This is going to be backed by a field called data, and data is going to be a... Wait. What am I doing here? Data is going to be a RefCell. It's going to be an RC to a RefCell to a vec. Is that what I want? Do I just want... how do I do this? I think that's right. I think that's right. To a vec of U8. Okay. And then we're going to have a function that takes in, like, we're going to pass this this RC in. Okay, so we're going to have new, which is going to take data, which is going to be an RC ref cell vec u8. It's going to give back a self. And we're gonna say self data, just that simply. Cool. And then we're gonna, like this, maybe you're thinking now you're gonna write like a getter method. You're gonna have like a get data or something, but no, because we're passing ownership of the shared buffer device away. All this thing does is link back to the token we still hold that lets us read this data at the end. That's what I hope is gonna happen. That's what I really hope is gonna happen. Addressable for shared buffer device. Okay, so what does addressable do? Addressable has a few functions. Memory. Oops, import. Let's find trait. Cool. So read, what does read do? Read, we are just gonna say, okay, 0. We don't read yet, unimplemented. We write, we say self dot borrow mut dot unwrap dot, where do we just go, add a as usize equals, oh no, we're not, oh, sorry, we actually just push in the value, right? We push it back. Because the idea with this, it's like standard out. We write to the one address multiple times, and that goes out on some imaginary bus. And then 0 all, we just, oh, and here we also say okay. And 0 all, we just say, yep, we did it. Successfully did nothing. Cool. So now when we come into our string test, we want to make what do I want? So we're going to make a new vec inside this thing, and then we're going to pass in, we're going to make a let IO device equal shared buffer device new. We're going to give it a clone of this data. So it's holding, you know, it's referencing this same thing, which is great, Now, all we pass in here is a RefCell new IO device. Actually, it needs to be a box new, right? Is that the only type we need? RC, not found in this struct, that's fine. And also cell RefCell. What else do we have? Address unused, cool. Address unused, that's fine. Don't really need to care too much about that, but that's okay. Use std rc and cell. Oops, make t. We're getting there. RefCell undeclared. RefCell. Okay. This needs to be mutable. This needs one of these. Did that say data need to be mutable? I'm not sure. I didn't read. Reading's hard. Unused, that's all good. Borrow mut, not found. Oh, yep, that makes sense. Let's get rid of that. We need to borrow the data, not the self, because self borrow mut doesn't make much sense. Now, here we go. Okay, we don't even get a result there. The panic is inside. That's good. We have some warnings, and that ran, and our tests blew up. What blew up? Nested field address. What's nested field address? DRF invalid type. What? What? Resulted if you try borrow. Yeah, cool. Yeah, cool. Interesting parts to Zig. Yeah, a bit of Zig chat going on. The compile time stuff is great. That's really exciting to me. Macros. Yeah, Rust macros are different. Rust macros just like, I don't know, it's not the same. It's not quite the same. Generics were weaker but stronger. Typography. Yeah, it's weird because like the ability to generate code so easily at compile time really makes the need for generics a bit weaker, I think. But yeah. Zig, you have to implement Bockstein manually. Interesting. Okay, where did I go? So this test shouldn't panic. That's not good. But this is good. This is actually going to work. So now I can come in and I can say, let's grab let data equal let content equals data dot just borrow actually. I don't need it to be mutable. And then I think we can say, can we say toString? No, I think I have to say stir from UTF-8. Stir from UTF-8. Can I do this? Dot unwrap. And then assert that the contents equals hello world. Let's find out. Wow, it's happening. It's happening. I unwrapped it. We got it unwrapped. We're set. We're set. Data.borrow. Okay, so we need to put apparently a ref symbol in front of this to turn it from a ref into a slice. And that's okay. I can deal with that. No, temporary value which is still freed. Okay, hold on. We can deal with that, however. Let data slice equal data.borrow. Right? We can't drop it. We got to hold on to this a bit longer. Data slice. We need to make this scoped at the whole function level. Nice. Okay, that now builds. Now, interestingly, shared buffer device new not called, because I'm definitely calling it. So I don't know why. Well, I don't know what that's about. I don't know what that's about. Run programs. I don't know why these things are never used. Now this, however, must be used. Map. We're gonna unwrap here, because that's kind of important. We're gonna unwrap here too. That's kind of important too. Tests don't count towards things being used. Then what do I do for tests for like things that supply functions like shared test functionality? How do I just ignore dead code? That makes sense. It would be silly if it wasn't the case, but it's also annoying that it is the case. Okay. Struct more nested fields. Struct. I think I fixed something to do with this, right? More nested fields. Cool. So that equals struct, var equals struct. We're dereferencing an int, which is somehow breaking. What has happened here? What's going wrong here? Foo. Yeah. So add 0. Deref invalid type. It's really hard. I don't quite have yeah. Panda X23, welcome. You're correct, it is Deja Vu Sans. Vibane is also correct that the font is set in the whole terminal, not just in Vim, but yes. Yeah, config test. Well, but this is in the tests directory, right? So this only ever runs as a test. These functions can't be used anywhere else. Anyway, yeah, that's something to think. I'm sure there's a best practice for this, and I just haven't found it. Okay. I don't actually know what we're doing when this error occurs, so that's not good. But I can probably guess. I'm gonna commit this real quick. Oops. Excellent. Okay. Do I have tests in the tests here? I didn't think I needed it. I thought cargo test would handle that for me. I thought the whole point of running cargo test and having it pick up test files in the tests crate was that they were just tests. Maybe I've made one assumption too far here. Panda X23, thank you very much for the follow, by the way. Really appreciate it. Really appreciate it. Okay, so let's have a look at lang. Let's have a look at lang. Code gen, and it must be in an expression. Deref. Deref invalid type. So we're dereferencing something. In this bit of code, more nested fields, a dereference is occurring, which is weird because there's no explicit dereference. Okay, so it must be in one of these other files, right? Also in block. Assign deref. Weird. So we really aren't throwing this error many places. Other tests. Other tests that use the code hash test. Yeah, the tests that use the code are marked test. So if we look at test struct, these tests are marked test. Yeah, oh, okay, I think I get what you mean. I think I get what you mean. So I do just need to go to common. And if I put like, can I just do this to the whole file? Nah, I've got to, okay. That's okay, that's okay. What the hell? CFG, oh. Wait, not CFG test. But that just means it doesn't. What? Oh, so it needs to like come first. Didn't know that. But it still says unused, which is great. Okay. Oh no, new is unused. Run per, things are still unused. I don't get it. I don't get it. Maybe it doesn't like it being pub. But then it's like, no, well, that field's private, which makes sense. Weird. Weird. Lots of things I don't understand going on today. Nested fields. Wait, which what are we doing? Because struct fields are like a dereference, but they shouldn't trigger this error, right? They shouldn't trigger this error. I don't understand why this test in particular. Oh, nested field address. Sorry, my mistake. It is actually in here. Nested field address. Okay, so foo.y. Foo.y should be a pointer to an int. So when we're dereferencing it, this makes sense now. I was looking at the wrong test. This makes sense now. So this line is triggering, this is saying that a is an int, not an int pointer. So this address of operator is potentially not giving us the right thing. And we have tests for pointers, right? We have tests for doing this stuff. So like we have like this test should pass. I'm going to comment this test out and see if any of these other tests fail. Okay, so everything else is fine, including our string test. Oops. Where is it? Test language. Apparently I can't search this with backslash, so we're scrolling. So these are all VM tests. VM, op fields, blah, blah, VM tests. Oh, hold on. Where are our language tests? Oh no, these are language tests. Sorry, they are here. They are here. Array return. Tests common, tests compiler, conditional, function, global, loops, pointer, string, hello world, passes. Let's go into string and change what we're looking for. If we look for something else, does it fail? It does. Oh, that's amazing. That feels really good. Being able to test this and actually test that we're writing stuff out correctly, we've actually got like a print and a string length. That's really good. That's good news for me. Okay, so Why does this one test fail? Why does this one test fail? Why does it think that the address of foo.y, the address of foo.y, so this must be the problem. This must be giving back an int instead of an int pointer for some reason. So let's look at lang. Let's look at codegen expression. Address of. Okay, fields. Let's look at resolve. What is the type of address of? Get fields type. Get. Oh, here it is. Here it is. Get fields type. Okay. Wait. So address of a set of fields is equal to the type of those fields? No. That's not right. It's a pointer to the type of those fields. That's just an error. That's just program error. Beautiful. That works now. Okay. So let's add that separately. Lang source. What did we change? Git add lang tests common. Oh, that last thing didn't commit, did it? Whatever. Cool. All right, beautiful, beautiful. That is really exciting. So I think that string's done. I don't know when I started strings. I lost track of like life and the universe for a while there, and I think my brain is too fried by Rust types to do anything else. But man, do you know what I can say with pride? We didn't do this. I can't even check this off. We didn't even do this. All I did was decide to not refactor it. So I don't know. What was the point? It really makes you think. Thank you so much to my wonderful chat who have been very supportive through this very, very troubling stream. Anytime you have to dive into the borrowed checker, seriously, Vibane, Bobbius, Vibane especially, put a lot of time and effort into me here to make my code better, and ultimately won the game of suggest the thing that I end up doing. So thank you very much. I found a solution. I solved a problem, just not the problem. Yeah. The point was to get unused code warnings that don't make sense. Surely someone else has Rust tests in a Rust tests crate that just like, surely there's a GitHub issue for this somewhere, right? Surely it's a known and solved thing. All right, we're gonna throw people on. We're gonna raid someone. We're gonna do a really cool raid. We're gonna raid a really cool channel. We're gonna find something good. Who is good? Who is a good streamer to throw some love onto? Always happy to get some requests. Music and learning studies. Test series for integration tests, not unit tests. I mean, these are kind of more like integration tests, right? These are actually, here's an entire program, compile and run it, and then verify the output, right? I have unit tests for individual instructions and things like that. So definitely, these feel more like integration tests. These are a complete program that get compiled and run. Christoph, I'm using the test here wrong. Okay, I'll wear that. These tests are too big to be unit tests. They are. I will fight that, but I also fully accept that I'm doing it wrong. That's my Rust experience. All right, we're gonna throw some viewers over to Christoph IT. Thank you very much, everyone. It has been, yeah, okay. I see what I'm doing. All right, love you all so much. Catch you next time. Thank you to the people watching on YouTube. Let's raid this channel. Bye.